Hello, everyone, and welcome to today's fireside chat, what we're calling Beyond the Sun, How Analytics is Revolutionizing Solar Operations. My name is Matt Chester of Chester Energy and Policy, and I'm going to be your moderator for this session. And today, this session is proudly powered by Chester Energy and Policy, as well as Vedeni Energy and Saviant Consulting. We're here today to explore how analytics is reshaping solar operations, from improving construction efficiency to optimizing labor requirements and driving down energy costs. With solar energy playing such a critical role in the global energy transition, understanding how advanced tools like analytics can optimize processes, it's more important than ever. So I'm excited to learn about what's going on today and will happen in the future from our panelists. So let's start by introducing those panelists. And first, we have Nagendra Cherukupalli. He's the Chief Systems Officer and Corporate Fellow at Xponent Power. His history in the sector includes addressing the dire needs of rural communities in the developing nations, as well as the smarts required to make lives better in urban centers through the use of state-of-the-art technologies. We're also joined by Patrick Brown, the Managing Director of Vedeni Energy. Patrick brings a wealth of knowledge and experience from diverse roles in financial management, strategic partnership development, operations oversight, leadership and human resources, technology integration, and business growth. And last but not least, we have Deepak Singh, the client partner and VP at Saviant Consulting. Deepak manages global programs and consults clients on their digital transformation journeys with artificial intelligence and cross-platform applications. His journey of 11 years in the IT industry has also made him an expert in areas like construction, logistics, travel, and the public sector domains. So here's how our session is going to unfold. We're going to break it down into 4 segments. First, we'll start with Nagendra sharing insights on how analytics can improve solar project processes, followed by some responses and insights from our other panelists. In the second section, Patrick's going to dive into a related topic tailored to his experience in what energy and solar markets look like on the grid and the ways that analytics can optimize those operations on a daily, hourly, even a minute-by-minute basis. Following that, we'll have another segment featuring Deepak from Saviant Consulting, talking about some interesting use cases that he's seen, kind of across the board on these topics. And then lastly, we'll bring it all together with a concluding discussion on both the 2024 energy trends and then predictions for the solar and energy landscape in 2025. So that's a lot of preamble by me, but let's turn to our experts and get started. And like I said, first we're gonna start with Nagendra and lean into his expertise. So from staging and building to harnessing energy and evacuation, analytics seems to touch every part of the solar project lifestyle. So can you kick us off by walking us through some of the key areas that you've outlined? And I have a slide from you that I'll throw up, and basically how is analytics making an impact?
Sounds good, Matt. And thanks again for inviting me to be here on this panel. I appreciate the fact that I'm sharing some of this thinking with all the other experts here on the podium. So appreciate the invitation and appreciate the fact that you've given me an opportunity to talk about some of these really interesting and really important topics. So let's first understand what is analytics, right? When you talk about analytics, you're talking about data analytics. What do you mean by data analytics, and what is the role it has to play in solar? I think that's the foundational question you're asking. And it's essentially analyzing raw data or assembled raw data and analyzing them to uncover certain patterns. Why is it important? Why do we even do this? Well, patterns are really beautiful because they help uncover some insights into what is happening there. And those insights come in pretty handy to make some informed decisions, like, better business decisions, better financial decisions, reducing risk, maybe even enhancing customer expectations and experience, as well as helping with retention of customers, etc. There are a lot of benefits to uncovering these patterns and insights. It'll definitely get us to a better place from where we are. So ignoring data that has been gathered is, in my opinion, a sin. So looking at the data and sort of deriving certain insights is actually good for making a continuous improvement process play out for you and the company. Okay, let's take a couple of examples here, right? So one of the first things you asked was, how does it help in staging? And I have this slide here that kind of walks through all the different stages. Can you guys hear me? Okay.
Yes, I can.
Yeah, we lost you for a couple of seconds, but we can hear you now. Yeah.
Okay. Yeah, I'm sitting in a place where the Wi-Fi is really strong. But anyway, so there are several steps that are involved in bringing up a solar plant. First of which is what is called as staging. What is staging? So the way the solar plant begins its life is you identify a customer, you go and sign a deal with them, you identify the project mechanics, like how big is it, where is it going to be situated, etc. And you sort of go through all the regulatory processes to get the approvals. And once that is in hand, then you start the process of construction. So for the very first thing you would do is order the parts, of course. And there are other things that happen before the site is actually prepped up. And for example, drainage and terrain, civil works, etc., fencing, etc., whatever is needed to be done is done. But at the time of staging, what happens is the material is delivered to the site, and typically this material is placed in the layout yard generally. And if you have good analytics, what you could do is understand how the site is going to be constructed, where the different rows of the technology are going to go up. And based on how the layouts are set up for the particular site, you can actually look at the material and distribute it optimally at each of the sites. So for example, if you're trying to build a block, all the relevant material that is required to build the block can be gathered together and distributed at that point so that the access to it becomes much easier, and you have less distance traveled from that point to the layout area and picking up the material. So this is an example of how you'd analyze the layout of the solar plant at the site, figure out what's needed, and sort of distribute it in an optimal fashion through analytics to understand what's needed, where it's needed, and how it's placed so that the access to it becomes easier. And the objective of that is to reduce the amount of travel time to bring the material to the specific spots. That's just one example. And you have to remember that every solar plant has a large land parcel that you have to deal with. So for example, if you're doing a 1 megawatt site, it requires typically a 5-acre lot. So if you're doing a 100 megawatt site, which is typically the size of a utility scale plant or even much bigger than that, you're talking about 500 acres to 1,000 acres if you're doing a 200 megawatt site. So that's a lot of land coverage, right? So this distribution, optimal distribution of material at the point where it's needed actually helps reduce the amount of travel time and thereby the corresponding labor content as well. That's just one simple example of how analytics can help with reducing the cost of construction. Another one that comes to mind is related to evacuation. That's the other question you sort of asked. How do we improve the yield or the evacuation and evacuated energy from the site? So let's understand how analytics can help here, right? You can actually have a land which is such a big parcel, but it's generally not flat. All the flat ones and the good land parcels that are available or favorable for solar are already taken. Now you have left with maybe I would call a second tier parcels, right? These have some undulations, some water ponds, some trees, some rocks, all kinds of obstructions. And so through analytics, you can actually identify all these ahead of time and through some surveying data and perform what are called as keep outs to make sure that those regions are not where you want to either place the rows or even get your traffic to go through. And one of the things that happens because of the land undulations is you have all these rows that are placed one next to the other, but they're not at the same level. And there is a potential for inter-row shading. That means if you have two rows that are neighboring rows, when let's, for example, use trackers as an example, a single axis tracker, then you have these rows facing the sun and tracking the sun through the day. And at times, either in the early morning hours or late evening hours, you can have inter-row shading. That means the shade of one row is cast upon the next adjacent one at some point during the day. And to avoid that, you come up with what are called as backtracking algorithms, etc. But what you can do with the analytics is understand the elevation differences between the rows, for example, by looking at the survey of the land, and then use that to tune your backtracking algorithms to minimize the amount of shading that happens across the rows. As you know, shade is an enemy of solar, and you don't want you want to absolutely minimize the amount of shading you see or the solar panels see during the day. And by appropriately tuning the backtracking algorithms, you can actually reduce the amount of shading across the rows and hence maximize energy. Again, there's an example of how analytics can help with improving the yield at a site. So I believe, just like the way I stated in the slide, every step of the solar plant construction can benefit from data analytics. So I didn't want to go through every one of these examples, but I just wanted to highlight a couple of them to say that analytics does have an important role to play. Leveraging it would help get to a better state than where we are in. And it's really an easier play to maximize output from an investment that's already been committed. That's how I see it, Matt.
Yeah, no, that's terrific. Thanks for sharing that. And I love, you mentioned the construction efficiency. Do you have any specific examples or success stories that you can just kind of share to demonstrate that in practice for us?
Yes. Previously, I was at a couple of solar companies that develop trackers, and these trackers will have to be distributed at the site. And we talked about how data analytics can help with the distribution aspects. Even on the construction, you can kind of come up with a similar analogy where, for example, you want to drive foundations to build rows of trackers. Now, the question is, do you want to go and pick up one post at a time and use the ramming machine to drive it down? Or do you want to have these posts sort of trail the ramming machine as it goes from one spot to the other, ramming in these piles? And that way you reduce the amount of travel time required to transport even from the distributed point to the exact location where it has to go in. This actually comes in really meaningfully handy in the case of modules, because modules, you have lots and lots of modules that you have to hang. And having a trailer that trails the two people or the three people that are installing the modules can enable a faster installation and reduce the amount of overhead required to move the material from point A to point B. And based on the product that you have chosen, you basically optimize the construction as well to get the rows built at a faster pace with reduced labor and less overheads. That's an example. I mean, a lot of little details that you have to get into for being able to explore this in detail. But the main point is analytics can come in handy even during construction, at the time of construction, at the point of construction, by appropriately applying certain optimizations to repeatable tasks, hanging modules, piling foundations, connecting wires, building strings, harnessing all of the energy into combiners, and from the combiners to the inverters. Every one of these is a very repetitive step at the site. So look at each one of these steps that are repeated. That's why I said uncovering patterns is important, which will lead us to get some insights into how the system can be built. And you can apply some optimizations to each of those steps to make it a little bit more optimal. That's an example of how you can apply it for even construction.
Yeah, and I'm sure that theme of identifying and utilizing patterns will resonate with our other speakers as well, and when we hear more about their specific areas. But first, I also want to hear, you mentioned, and it was on your slide, things like labor requirements and how that's a challenge for solar operations. So can you talk to us about how analytic tools come into play for the world of workforce management?
Yeah, absolutely. Getting prior information about all the labor that is out there that is going to build your project is actually helpful. If you have several, I'm sure these labor pools can be broken up into skilled labor and non-skilled labor for the given task. So if a particular task requires maybe a couple of skilled people and one supporting staff, like a non-skilled technician that's following the two skilled people, just identifying that subset and making sure that that's exactly what is deployed at the site, and they move in a very organized pattern from left to right or right to left or whatever the flow is, and coming up with a deterministic way of getting them to operate from one point to the other helps us to overall reduce the labor content. Otherwise, if you end up, for example, with 3 skilled labor, you're going to feed Paul from Peter, and there'll be some other location where you'll have more unskilled people. So distributing the skilled labor, making sure that the optimal number of people are deployed at each point, and getting them to follow a certain pattern of construction that is methodical, helps improve the quality, number one. Number two, it becomes easier to track what's being done. You can actually have analytics tools that are monitoring what's happening at the site and sort of report back to the headquarters as to what is happening and how much of the activity has been completed. And then more importantly, you don't have to have excessive labor at the site. So these are all things that can be done at the site to reduce the overall what I refer to as the total cost of construction by applying analytics. Does that make sense to you?
It absolutely does, and I think that's helpful information and background to share. And kind of the last question I'll have for you, and I'll also invite Patrick or Deepak to weigh on in this question too, because I think it's kind of overarching. But what are some of the ways that you think the industry is falling short about truly taking advantage of all these opportunities that you're talking about, and what's causing those blind spots to exist?
Yeah, great question. And this is, again, my opinion, and I invite the other panelists to chime in as they see appropriate. These are my observations, right? Most of the industry, at least the companies that do deliver products in the industry, are heavily focused on making the product better. They'll add more new features, they'll add more new capabilities, and they want to create some differentiation between a product A and a product B in the industry. And there's much focus on how can we get our product to shine better than the other one. That seems to be the focus of the industry. But what they might be missing is the low-hanging fruit, the total cost of ownership. How much does it cost to get this product into the ground? How can we optimize it? Can I create some methodologies for optimizing the construction of this product? They know their product really well. Now, if they can extend that knowledge and create some construction support methodologies, your product will go into the ground much faster, and you will reap the benefits of being the lowest labor content solution. I think that is the part that the industry might be missing, and one good way to do that is to bring in analytics, as we've been speaking. And I also want to put a plug in for AI. That's the buzzword of the day today. You can actually bring in fuzzy logic into the controllers, right? Today, all of the algorithms that the controllers use are very, very specific, and maybe a derivative of some NREL algorithm, right, to figure out where the sun position is. I'm again talking in the context of trackers, which I know well. So you figure out where the sun position is, and you sort of track to that position to maximize the amount of solar irradiance content dropping on the modules to convert that into electricity, which is all good, but that requires a lot of very specific parameters to be set to be able to control the motion of the controllers. Why can't we use fuzzy logic with support from neurons, right? Neural networks, which will actually enable you to give imprecise data, but still arrive at the same or a better solution without a lot of computational complexity, I would say, for identifying the exact location of the sun, but applying fuzzy logic. And of course, the quality of the fuzzy logic is a function of the training set you've used to train the controller. So bringing in some newer technologies, newer abilities into the solution would help get the solar plant constructed more efficiently. Point one. Point two, another example I'm thinking of, as you asked, is drones, right? Drones have become a big part of the overall everyday life now. why can't we bring in drones into monitoring the solar plants and do flybys and sort of look for any quality mishaps that might have occurred because of continuous motion. Remember, these are built for 20, 25 years. Some bolts may have gotten loose, some nuts may have fallen off, some torque marks may have moved, or the bolts may have moved from the torque marks. All these can be recognized quickly, and you can actually have a lot more preventative actions taken at the site to make the plant sustain the 20, 25-year life more easily. So bringing in drones, analyzing through image processing what is going on at the site is another example of how people can leverage existing technologies from adjacent industries into the solar industry. So you can come up with so many more examples like that. But point is, focusing on the product is awesome, but insufficient. You need to think about how do you look at the overall total cost of ownership, total cost of construction, total cost of the system over its lifespan, and sort of bring in software, bring in image processing, AI, fuzzy logic, all kinds of newer capabilities that exist out there into the solar domain to take advantage of those technologies. That's at least my opinion.
Great. And like I said, I wanted to put the same question to Deepak and Patrick. Do you have any insights on falling short about how the industry is doing that and why?
And again, first of all, thank you for sharing your inputs and thoughts, and you have a wealth of experience in solar industry. So, uh, I think one challenge I faced initially when I will share my couple of use cases that we have done, and you rightly mentioned the analytics and AI has been the change to solve some of the problems on operation and efficiency, and making sure the plan versus actual forecasting that we are using is more than 90%. But I think the challenge is probably, and I wanted to know your thoughts, the data, right? To do analytics, you need data, and data collection sometimes has been challenging, and getting the right amount of data has been challenging, because then once you have the right amount of data and accurate data, then you can start using the algorithms to start building the models and to predict and forecast. So do you see the same challenge utilized at your end, or have you faced the same challenge as well?
Absolutely. This is an awesome question, Deepak. So we talked about how data analytics can help improve the situation, but we didn't talk about how can we collect the data to get to the data analytics, right? That's the foundation that we need to first build. Unless the foundation is strong, you can build a good capability on top of it. So it's a great question. So how do you ensure that the data, first of all, is collectible and then can be processed appropriately? So the collection piece is driven by many things, right? One is customer willingness to share the data. Customers should be willing to allow for this data gathering to happen. I mean, look at how the medical industry works, right? They have a lot of data about the patients, but they anonymize the data and use the collected data as a way to advance the state of the art in the medical industry. We have to be doing the same thing in the solar industry. We have to anonymize the data. First of all, allow the product companies to gain access to the data. So that's the first barrier to overcome, getting approvals and getting over. There's some hesitancy in the case of customers to share the data, and I don't know what that is, especially if you can allow for anonymizing to happen and they can be on top of it. So getting access to the data is first and foremost. Secondly, you have a huge dependency on communication layers to ensure that there is no interruption in the data gathered. So again, that is more a technological issue that can be solved, and with the newer technologies that are coming about, like Starlinks and so on, hopefully that will get better over time. But getting the data gathered and transported to the site of the analytics is the next hurdle to overcome, and that's somewhat of an easier problem, I think, to overcome. And the third one that I can think of is no matter what you do, it's not a happy path all the time. There is always going to be data interruptions and data gaps that are going to get created in the data that's gathered. So you have to have somewhat of a novel approach to do the data gap fills. And that could be either by having local historians at the site and gathering the data and having backflood from that site back to the data systems so that you can bring the data in and fill the gaps, or have some sort of predictive methods by which you say, okay, it has been so and so up until now, and it has been so and so beyond this point. So it's likely that this is what happened in the gap that I have, and sort of do the data filling. So creating congruous data set becomes a vital pre-requirement before you can run the analytics. So it has dependency on as I said, customer willingness, the communication technologies, and some smarts that even the data gathering processes need to have to be able to make the data more meaningful. Did I answer your question, Deepak?
Yes, absolutely. Thank you.
You're welcome.
Wonderful. Yeah. Thank you, Nagendra. These insights really do demonstrate the tangible value analytics can bring to solar projects. And now I want to turn to a different angle of that in the segment that'll feature Patrick. Vedeni Energy has a strong focus on the live markets that drive the grid. So given that and our topic today, I'm hoping you talk about how the evolution of data analytics has improved solar generation forecasting, and what role does that play in optimizing the participation in broader wholesale markets?
Sure thing, Matt. So the evolution of data analytics has been transformative in solar forecasting. The use of advanced machine learning models, which now integrate historical weather data, satellite imagery, and real-time meteorological inputs to predict solar output with high precision. This reduces some of the uncertainty in the day-ahead to real-time market participation, which allows solar operators to submit bids that are closer to actual generation. By minimizing the forecasting errors, these tools can help avoid penalties for imbalances that you see happening in some of the markets, improve grid reliability, and then maximize revenue streams for the asset owners. As wholesale markets increasingly reward predictability and reliability, accurate forecasting becomes a key competitive advantage for the solar operators.
Right, and I imagine it's not just the the forecasting, but also just maximizing the value of assets once they're in there, of solar and storage, and how owners can utilize them best in the wholesale market. So can you talk about how that those come together, especially in terms of things like price arbitrage, ancillary services, things like that?
Are you talking about the competitive bidding strategies, Matt, or?
I'm just talking about the ways that using analytics can maximize the value of the market. So whether it is those bidding strategies, or just once they're deployed, what can the owners best use?
Sure. So the data analytics can provide some very deep insights into historical price patterns, peak demand periods, and system constraints, which enables the solar developers to craft more informed bidding strategies, right? Allowing them to take advantage of more revenue streams and to kind of maximize the profitability of their assets. For example, analytics can help predict price spikes or periods of negative pricing, which can allow solar operators to adjust their bids accordingly. By analyzing competitor behavior and nodal pricing trends, developers can also identify some of the strategic opportunities for maximizing revenues. Furthermore, the analytical tools can simulate market scenarios, helping the solar providers test and refine their bidding strategies in response to evolving conditions.
Great. And then, when we're talking about solar and these wholesale markets, I know curtailment is a major topic, and it remains a challenge for solar providers in CAISO and ERCOT and elsewhere. So what are the ways that utilizing data analytics can help mitigate those curtailment related issues and ensure solar generators are able to operate profitably?
Sure thing. Curtailment often results from grid congestion or oversupply of a particular resource type during the peak solar production hours. Data analytics can help the asset owners identify patterns and the root causes of curtailments by analyzing grid constraints, transmission flows, and pricing data. And armed with the insights from these analytics, the solar operators can explore solutions such as coordinating with grid operators to improve scheduling, or pairing solar with storage to shift energy delivery to off-peak hours. Additionally, analysts can also pinpoint more favorable interconnection points for future projects where curtailment risk is lower. Over time, these strategies can help minimize lost revenue and improve utilization of the assets.
Right, and I want to give the Deepak and Nagendra a chance to chime in here if they have anything to add. And maybe Nagendra, I'll put you on the spot because again, you're talking about these major solar projects as well. Are you seeing these factors that Patrick's talking about be considered during the construction process and the planning process as well?
Absolutely, because we don't want to overproduce and we don't want to underproduce either. So how do you balance it, right? How do you know what is the right amount? So it all depends on what the regulatory body is expecting from us in terms of the amount of energy to be delivered on call, basically. And today, unfortunately, solar has still not become the baseline energy source. It is sort of still somewhat of a variable source that runs, like they can replace the peaker plant for not real base loads, right? So again, as Patrick was saying, having proper forecasting methods and understanding what the peak demands are likely to be, and sort of using those as a way to derive what the right, quote unquote, right sized project plan would be, is actually something that the customers kind of typically do before they arrive at a number. They'll say, I want a 159 megawatt plant. You wonder, why do they need 159? Why is it not 150 or why is it not 175? The point is, these are the types of numbers from the utility company that actually help drive the sizing. So yes, even there's a lot of data processing, and you can call it as analytics, but basically there's a bidding aspect that follows based on the forecasting and demand, and maybe even curtailment. These are all the factors that come into play for assessing what the size of the plant is. And that's typically what I have seen the industry or the customers in our industry do. So it chimes in really well with what Patrick was saying. One other point I want to mention is, you asked about curtailment. How do people make money when there's curtailment? Because curtailment is like basically pissing away the energy that you created down the toilet, right? How do you prevent that? So you have techniques like storage, really, that help you to sort of absorb the excessive energy that the inverters otherwise would be cutting off. And then you bring it back when the demand is either high or when the production is lower. Because during late evening hours, when the demand is peaking, the solar plant is unable to produce as much because the sun has already started going down. So that's when you can sort of bridge the gap by reducing the amount of curtailment and transforming or translating that into recognizable revenue by using storage as a way to do the shifting of the energy consumption. So it's actually all those play together. It's actually a pretty complex program or problem to solve. And it's amazing how the utility industry has done such a good job of guaranteeing such high specs of delivery and still dealing with all these variables on the back end.
Absolutely. Yeah, that's good insight. And Patrick, I want to go back to you and something you mentioned earlier in bidding strategies for day ahead in real time markets. So I love if you can dive in more about what data analytics does to help solar developers kind of plan for that.
Sure. So along with some of the analytics that we were talking about earlier, when it comes into the construction site location, things like that, you also have to look at what the historical price patterns, with the peak demand periods, some of the common system constraints within those areas. And analyzing that data enables the solar developers to kind of craft more informed bidding strategies. Looking at price spikes, there's periods of negative pricing now in certain parts of the country when solar is overproducing. But being able to analyze all that data and all those different parameters gives the solar operators the ability to adjust their bids accordingly and their bidding strategy accordingly. By looking at all of that data, plus looking at competitive behavior, not just of the solar developers, but also other types of resources, and looking at notable pricing trends in that particular market, that particular area, can also help developers identify some strategic opportunities to help them maximize their revenues. You can also do some offline scenario analysis. We'll use some analytical tools to kind of simulate the market scenarios that help the solar providers kind of test and refine their bidding strategies in response to evolved market conditions to help them in kind of crafting some of those strategies.
Yeah, I think that makes a lot of sense. And kind of wrap it up, and this will be, again, a good one for Deepak and Nagendra to also weigh in on if they have follow-ups to you, Patrick. But what opportunities do you see moving forward for data analytics to further transform the role of solar in these wholesale markets, and what are the barriers that need to be overcome first? What can we anticipate coming ahead?
I'll be honest. I think the data, as far as data analytics goes, the future is wide open. You have things like enhanced grid modeling, AI-driven analytics. These things will be able to enable more efficient integration of distributed solar resources and get them integrated into the wholesale markets, potentially through virtual power plants, distributed energy resource programs. Real-time data sharing between grid operators and solar developers can further improve reliability and market participation for those resources. As to some of the barriers that are still in the way, you have some inconsistencies in market rules across the different ISOs and RTOs in the U.S., which could present some challenges with data standardization. And we also have cybersecurity risk, which is something that's constantly in the back of our minds that we have to watch out for. I think another thing that we run into, and this goes back to what we were talking about earlier in the construction piece, is I had an interesting conversation with the CIO of a renewable development company once, and we were talking about data strategy and data analytics. And the pace at which these companies work, they're very fast paced, constantly developing new projects, looking for new projects, working on the financing, et cetera, right? His comment to me was, he goes, I don't have time to spend on that. He goes, I don't even know how many laptops I have, let alone have a data strategy, right? So I think, be able to slow down and think and actually come up with a formal kind of approach to data, a data strategy, how you're going to use that data, what data analytics can do for you. Us kind of stepping back and taking a look at all that will help us come together and come up with some of these ways of addressing some of these challenges. And some of this is going to require collaboration among multiple stakeholders, which will help create a more transparent, efficient, and secure data ecosystem that supports the growth of solar in the wholesale power market.
Yeah, and I'll invite Deepak or Nagendra if you guys have any thoughts on what Patrick shared.
I think one thing I wanted to understand, Patrick, you have seen this industry for long. How difficult is for your customers or the solar power generators to adopt to this new technology, right? Whether it's a hardware technology like Nagendra mentioned, drone, or using AI technology to help their business.
Yeah, so I would, traditionally our industry has not been a early adopter, right? We haven't been early adopters of technology. We're a very conservative, kind of slow moving of industry in general. Your smaller companies, your new technology companies, your small renewable developers, these companies tend to be a little more advanced as far as technology goes, a little more adopting of technology, but still may not be front runners on the edge of technology, right? And so they're more of a, I'll wait back and let me sit back and see how it works out before I adopt a kind of approach, right? And so you really have to see that proof of concept. They have to see how it's going to benefit them, how it's going to help them with their overall objectives within the markets, right? They want to clearly see the benefits before investing the time and effort and money into these new technologies. Back to the example I gave with the data analytics with that large renewable company, they didn't necessarily not see potential benefit in the data strategy, data analytics. They just hadn't been able to quantify that as far as their particular organization went. which really kind of slowed down their ability or their willingness to want to invest in those types of technology. I think, one thing we have to do is clearly show them how this is going to benefit their specific organization and help them drive revenue.
Got it.
Great point. Great point, Patrick, and good question, Deepak. The thought I had was, this is Patrick mentioned this. Utility industry is like a slow turtle. So they move at a really slow pace, but they want to know the path on which they are ahead of time before they start moving. And this is the proof of concept point that Patrick was making. And what's in it for me is the first question they always ask. So it's a little bit harder. So it's really a mindset issue that is stopping the utility industry from actually gaining a foothold in adopting these newer technologies. But I believe that is also changing. People are beginning to realize that there is opportunity to be had if we are able to take more risk. And so sort of there is I would say there's a slight shift in the thinking from being a totally risk-averse industry to being a little bit more risk-accepting industry. So that is an area that's actually a harder problem to overcome, getting acceptance by the utilities. Hey, why didn't you try this new capability? Why didn't you try this AI-based forecasting methodology for bidding processes? They have a hard time accepting that because there's immediately, hey, what is in it for me? So I think this mindset change will happen, but it might take a little longer latency time for it to happen. So I think that's really what is, in my opinion, stopping the industry from being on the forefront.
Excellent.
Yeah.
No, this is some great discussion, and I thank you guys all for it. And with that, let's move on to our third segment, which is focusing on analytics and practice and some case studies featuring Deepak and his insights from Saviant. And I just want to start by asking, I think it was mentioned earlier that AI is the buzzword. Can you talk about ways in which AI is helping to improve the installation, monitoring, and maintenance of solar installations and what you've seen in practice?
Yeah, sure. And I think like what Nagendra mentioned at the start, like I think the great presentation that he had, like how the solar industry is facing problem with respect to operation efficiency, right from the start, from the construction to layout to start producing the power from the solar industry. So one of our customers, and like Patrick or Nagendra mentioned as well, that you start adopting to technology or when it becomes really a need before that. So I think when they started working with them, they were so solar panels are sourced from various suppliers, and these panels are stored and then taken for installation where they are there in operation in the solar plants. And they were doing, while they get the solar panels from the third party supplier, they get the EL images as well, electroluminescent images of those solar panels as well to check the conditions. And before that, they were using the manual sampling to check whether all the solar panels they have in the warehouse itself is at the right condition before they get into the solar plants. And obviously, when you rely on manual intelligence and manual sampling and efforts, and when it goes into the plant, and after some time during the plant, they used to find some defects on the solar plant, whether it's a crack, whether it's a black spot, or there's a micro cracks or cell cracks. And then they used to do the investigation retrospectively, where was this originally came from the third party suppliers, or what is all these defects came in while during the installation process during the solar plants. So we worked with them to build an AI solution to replace the sampling method of inspection and therefore make inspection more accurate and exhaustive, which allowed them, basically we used image detection on all those EL images. We used RCNN and neural networks to start identifying the objects on all the images shared by suppliers before in the warehouse itself. And then it will allow them to early defect detection, prevent warranty issues later. These images were able to inspect very early in advance, more quickly, thereby avoiding logistic cost as well. before they goes into the solar plant after the installation. And the turnaround time of detecting and reporting an issue to suppliers got reduced drastically by 60%. So that's the part where from they get this the solar equipment from the third party supplier and before it goes into this installation. And after the installation, they had a drone technology in place, and the drone used to capture images, and which allowed us for visual investigation during operation and highlight malfunctioning in drainage or cracked panels or vegetation growth. Let's take dust for example, right? And it is a major cause of degradation in solar output. AI powered images we used analyze can be used to detect dust accumulation on solar panels as well. And deep learning models was able to analyze solar panel captured images to classify them as clean or dusty. Basically, we use classification technique first to identify whether this is a clean image or not. Does it have any type of defect or any type of object detected? And then type of object, whether it's a dust, there's a shadow, the black spot, it's a cell crack, it's a micro crack. So I think this is where AI has evolved, and I think their operation, the cost of equipment has reduced, and eventually they have become more profitable in their business right now.
Excellent. Yeah, and beyond the AI, we also know that many solar farm operators still rely on manual intervention for some day-to-day efforts and troubleshooting. But is there ways that analytics can be used to reduce that dependency and empower teams to do that more manual work in a more efficient way, maybe?
Yeah, I think traditionally asset and operation generates a lots of data, which then a data team or team of analysts works on to generate some usable insights. But this is a time consuming process, because then you have to create a visual reports, uh, and then you have to analyze it and then create KPIs out of it and then start making decisions. Whereas self-service analytics make it easier for everyone to access and use data insight. It comes with user-friendly interface, drag and drop tools, and automated KPI calculators. So automatically calculate the insights and the KPIs that reduce the need for specialized data teams and save cost. End user of this data insight, right? Like the engineer, the operation and maintenance team, the business team can directly query the data, explore real-time telemetry, compare the battery pack performances, inverters, string performances, or even create your own custom KPIs. No coding required, basically. All this self-service analytics, you don't need to code. Don't need to has to have a high-end technology skills to do this. And we solved the similar problem for one of our customers who are into selling discarded batteries from automotive industry, right? So automobile industries like Nissan, Ford, they get all those batteries which are not in use from their customers. So they use these batteries to recharge them using solar, and they created a battery packs which has a sensors connected and which used to collect the data. And we created a real-time asset monitoring system and self-service analytics for them, their team to analyze it and make sure whether it's going discharging. Then you have to go and make the decision more proactively rather than reactively. And the best part is speed up the decision making, helps teams to respond to issues more quickly, and foster a culture where data driven becomes the nature across the organization, right? You should be making decision based on the accurate data, and you should be able to make faster decision to take more proactive actions rather than being reactive.
Yeah. Actually, I want to pick up on 2 points that you just made, Deepak. One is, there are all these SCADA systems and stuff that are available at the sites to integrate all the outputs from different tools and sort of make supervisory decisions and stuff. That's a space where people can bring in a little bit more data analytics and AI capabilities to make them a little bit more smart, I would say. A case in point, right? I mean, most of these sensors that we use in a solar plant, like the snow sensors and wind sensors, they're all acoustic sensors. So if you look at a sensor, for example, it's acoustically looking down on the ground from some height and checking to see if there's any accumulation on the ground. And based on the accumulation, it just goes ahead and says there's no accumulation. And then apply a little observation, enter lock or enter, and go perform certain operations. And that can lead to a lot of false positives. So, for example, integrating integrating temperature sensors and maybe even image recognition sensors, like a camera-based image recognition sensor, and sort of collating that with what the snow sensor is observing will lead to a much better outcome, for example. So whenever you have a false alarm, you're losing production. It means your energy delivered is going to be lower. And we've seen this happen even in the middle of summer. The snow sensors are triggering because somebody kicked a little stone under the snow sensor, or maybe there's some growth that happened and that growth looks like accumulation and so on. So there are opportunities even in the existing sensor space to make them a little bit more capable by integrating these image processing, image sensing type of technologies. That's one point I wanted to mention. Just as Deepak was speaking, I thought of that. Another example is cleaning. Sorry, go ahead, Deepak.
Yeah, no, so I think great point, Nagendra. Yes, I think right now we have one customer who are into inductance. They create large furnaces for all these big companies who are into creating metal through using inductance heating. And these furnaces are like huge, like they are of a room size, right? And their maintenance and proactive maintenance becomes utmost important. If you don't do the proactive maintenance at the right time, you have a property loss. They lose lives as well because they are so huge in size. So now they have all adopting to new technology like LiDAR. So they are using thermal images. We are working with them to analyze those thermal images and do the relining and inspection at the right time, so that they're not only able to proactively maintain it and reduce downtime, but save cost on properties and lives as well.
Yeah, absolutely. Safety is a big deal all the time. So that was one point I was thinking about when you were speaking earlier. Second thing that I talked about when you mentioned about soiling, lose a lot of energy because of simple accumulation of dust on the modules, right? Especially in deserty conditions, there's a lot of unwanted debris that gets collected on the solar modules, and that reduces the amount of energy you can get out of it. So cleaning systems have come about, right? A lot of big companies that are trying to do these robotic cleaners. So that's all awesome. It's really good in that in the sense that they're moving in the right direction. But think about it, right? Each of these robotic cleaners is 60 to 80 pounds weight, and a couple of people are needed to move these cleaners from one tracker to the next, one surface to the next, and so on. The whole point of automation is mitigated by needing a human intervention to move these cleaners from one row to another. Why can't we come up with a technology like a drone technology with a bunch of bots that it picks up, drops it on not every row? You don't need to clean every row. You only clean the rows that have the dust on them. So being able to recognize that is first improvement. That also data analytics can help with that, right? So instead of cleaning 5,000 rows, you clear maybe 10% of the rows that have the dirtiest situation, and that will improve the productivity. So that's point one, identifying those rows and then cleaning them. And then cleaning them by having these drones bring in the bots, like the Roombas of the solar system, that drop onto the thing. They clean the thing, and then the drones pick them up and go to the next one that needs to be cleaned, etc. Again, if you know the layout of the site, you can through analytics identify the rows that have to be cleaned, and then program the flight paths to the drones for them to be able to fly from one to the next and do the cleaning. And you can actually do this in the middle of your night when you're not impacting the production, right? So this is how analytics can help, identifying cleaning rows, and then automating the flight paths and getting the drones to go clean it and come back and recharge, etc. It's a really important low-hanging fruit that people can develop by applying some or bringing in technologies from other spaces into solar.
Absolutely, yes. I think drone is probably the one is trending right now as well. Few of the use cases that we see, they have started using drone as a technology to at least capture the real-time status of the solar cells and panels, and then use those to make faster decisions, right? Because when you still rely on human intelligence to do a periodic investigation and periodic inspection, by the time you don't know whether there's already some of the solar cells are not working, Some of
Correct.
them have been already in a dysfunctional space. So absolutely.
Yeah, they're using IR cameras extensively now, which is a good thing. That's a step in the right direction. They can extend it even more into cleaning. They can extend it more into quality assurance checks. They can extend it more into making sure safety is there. This is in the case of an emergency response. There's a fire that broke out. You don't want people to be deployed there. You can fly these drones. Already these technologies are slowly coming in, but we need a lot more systematic and methodical adoption of these technologies to improve the overall performance of a solar plant.
Absolutely.
Great. No, very fascinating discussion. And another technology that we've kind of touched on here and there, but I want to focus a question on it for Deepak is energy storage. And it's obviously batteries and storage have such an important role for broader renewable energy ecosystem. So where do analytics come into play to make storage assets smarter, more responsive, and ultimately profitable?
Yeah, I think we are witnessing to a transition from basic data collection to fully integrated AI-driven platforms. Today, analytics are moving beyond just retrospective reporting, right? What we talked about, where advanced systems can now predict equipment failures, recommend maintenance schedules, optimize charging and discharging cycles based on real-time conditions. Like I think Nagendra talked about using drone or using some other smart technologies to collect the data and use the data in the right way. What we see in the near future is this system will leverage machine learning models to anticipate shifts in the grid demand, market price, and weather patterns, right? Use third-party data as well, weather forecasting data, market price data to enable operators to fine-tune their storage strategies on the fly. And it's an evaluation for asking, right? So what happened versus what should we do next? I think that's what everybody is moving toward. Ultimately, making energy storage asset more resilient and profitable. Like Matt, you asked about predictive analytics forecasts what happen next, like predicting inverter or string outage, right? What Nagendra was mentioning, like taking a more proactive actions. While perspective analytics can go a step further, they recommend specific actions. So they not only just tell you what if there is a dust and you have to clean it up and how badly it is and what it is causing. So for energy storage, this could mean advising operators when to charge or discharge based on the project market price. As the storage systems integrate with the grid, perspective models can coordinate energy delivery with the peak demand times, right? As per the market, then you should be able to make the decisions at the runtime or charging or discharging. This result is a very proactive and data-driven operation. So yeah, I think AI is and machine learning and using the data analytics is the future to make that decision from the market point of view as well, not only from the installation and forecasting.
Excellent. No, this has all been fascinating, and I want to thank our panelists. It's you've all made it clear how analytics are evolving in some exciting ways across the industry. And now, as we wrap up, I want to broaden the conversation to just look ahead to the future of solar and energy more broadly. And so, as we close out our session, I just want to give each of you a chance to share your thoughts on key energy trends that have shaped 2024 and what your predictions are for where solar and the broader energy sector will head in 2025. So, Nagendra, I want to start with you. What's an upcoming trend that you're watching closely? You're on mute.
Yeah.
Sorry, I didn't realize I was on mute. Yeah, I'm looking at integration, right? The integration is an overused and abused term, but it actually is very meaningful for us here in this space. So think about the world that we're trying to solve, right? There is a world that we are trying to address. There are producers, like solar producers and wind producers and hydro producers and nuclear producers, etc. on one side. And there are consumers, who are all the people that need the energy. That could be industries, that could be machine shops, it could be simple lighting requirements in a home, etc. So they're the consumers. And there's a hard spec that needs to be met. 99 point something percentage for reliability has to be there. So how do you make this all cook together in a harmonious way is the challenge of the day. it continues to be the challenge of the day because the demands are all the time increasing, especially with all these data centers coming online, etc. The demand is always going to go up. The producers have to keep up. The integration and the sharing of information, the tight networks that I think Patrick mentioned is actually going to be quite important. So communication platforms, data analytics and the corresponding AI and related technologies, bringing them into this integration, let's say recipe, is going to help us to get to a more balanced production consumption system, which is what we do today. It's a synchronous machine at the end of the day that's delivering all the energy and keeping that humming, despite the fact that the demands are changing and the productions are changing, is really a challenge of the day and continues to be an opportunity for newcomers to study this and come up with solutions. Simple solutions don't have to be all encompassing, but think about a point problem there and solve it and come up with a newer solution. That's where the opportunity is, right? So state of the art needs to keep moving in the direction of better integration, tighter fits between producers and consumers, markets and bidding and storage and variables, production sources, etc. Bringing all of that together into a harmonious system is really exciting to me. That's the problem to be solved. That's what requires new thought, new technologies to be brought in, and continue to drive the state of the art forward.
Great. Patrick, what about you? What's exciting or maybe concerning to you about the road we have ahead?
I think one of the things that I'm really kind of paying attention to is we're seeing a lot more growth with renewables on the distribution side versus the wholesale market side. And there's a lot of reasons for that. But it'll be interesting to see how AI and predictive analytics and everything helps to kind of evolve that. How do we use data-driven demand response and energy efficiency programs? How do we leverage that data to develop some strategies around that? Analyzing consumption patterns can incentivize consumers to adjust some of their uses during peak times, enhancing grid resilience and reducing the need for additional generation capacity on a wholesale side. So I think overall, just seeing how we use this data to kind of drive that demand response on the distribution side, how we can use it to help with asset management on the distribution side with predictive analytics. I think that's really going to be exciting to see how that plays out over the next couple of years. And then, for me, the long-term kind of thing is what's going to happen with quantum computing, right? I mean, you see advances being made now, and you're probably 5+ years away from something significant in our industry, but just the sheer options or the potential impacts on AI and predictive analytics and things like that is just going to be huge. I don't think any of us yet can predict what that's going to be, but I find it pretty exciting to kind of monitor and watch and think about how this is going to help us in the future.
Absolutely. Yeah, exciting times. And then Deepak, why don't you close us out with this? What are the biggest opportunities or innovation and excitement that you see on the roadmap ahead?
But I completely agree with Nagendra and Patrick, what may have mentioned, and I think what Nagendra touched about, what we have been doing in especially in manufacturing industry from last 4 or 5 years to bring the hardware, software and data together, right? And create an intelligent solution versus creating just a solution. So I think once you bring hardware and software and data and build an intelligent solution, you have all the data which will require to do the right analytics. And I completely believe, based on what we have seen, that data analytics, whether using AI or ML, will be a key enabler in the continued growth of solar, wind, and battery storage. Its ability to enhance the efficiently, reliability, and cost effectiveness of the renewable energy will accelerate the global energy transition. I think these guys are expert, but I think this will help renewable energy generation surpass coal for the first time and meet a significant portion of the growing global electricity demand using solar, wind, and storage, battery storage.
Absolutely. Well, one small thing here is sun is at least unbiased. It's available everywhere on the globe without any
Yeah,
bias. So it's
true.
ubiquitous and it's a great source of energy. We just have to figure out how to use it more and more. So those are all opportunities. It's an exciting place to be. We just have to find the newer developments that are happening in adjacent industries and adapt them to our industry to make the industry move forward. So it's an exciting opportunity, exciting time.
Sure. Yeah.
Absolutely. Couldn't agree more. All right. So I'm going to give you all one last question, and it's going to be more of a lightning round style. So just one or two sentences as the lasting message for our listeners or viewers to take away from today. And that's just if you could give one piece of advice to companies looking to maximize the value of analytics in their solar projects, what would it be? So Nagendra, let's start with you. What's the one piece of advice you hope they take away?
Change your mindset. Don't think data analytics is something that is a separate entity that you have to make an effort to bring it in. Let it become part of your day-to-day routine, and it has to become part of your day-to-day observation to find ways to improve.
Love it. Yeah. Patrick, what's your one lasting piece of advice?
And to tie into that, I would say have a strategy, have a data strategy that supports and ties into your overall corporate business strategy, and know how you can use data and data analytics to help drive that.
Perfect. And Deepak, you're batting cleanup here. So what's your last piece of advice?
I think to get the data and have the right data in place, you have to integrate hardware, software to create a solution which will allow you to have the right data in place and then use the data to perform analytics to predict and forecast, which is a need now. It's not more of as a good to have. It's a need right now in this industry.
Absolutely. All right. Well, that was terrific. Thank you once again to our three incredible panelists for sharing your insights today, and for everybody who's going to be in the audience joining us to learn. I hope this session has sparked ideas and inspiration for how we can continue to push the boundaries of what is possible in solar energy. And a thank you as well to our sponsors of today of Chester Energy and Policy, Vedeni Energy, and Saviant Consulting. If you have any further questions or want to continue the conversation, feel free to connect with us or the panelists after the session. And until next time, thank you and have a great day.
Thank you, everyone.
Thank you, Matt, Patrick, and Deepak. Thank you.
Thank you.